Right, so in this sort of panel, we're going to be looking at, as he said earlier on, the hardware aspects of security. And I'd like to go through each of my individual panel members here, talk about what you do, what it is, and what companies you're from.
Sure. So I'm Shahram Mossayebi, CEO, co-founder of Quantique. We provide an end-to-end security for connected devices by harnessing quantum tunneling inside silicon on the device side to provide unforgeable identities inside each device. And then we have a software side that take advantage of those unforgeable identities for protecting the device on the supply chain, and then also on the cloud side to connect the device to the back offices and also protect the device, security of the device during the device lifecycle.
And
yeah, so I'm Stephen Cooreman with Silicon Labs. Silicon Labs is a chip manufacturer. I'm the embedded software security lead, so I built the firmware that goes into the secure enclave in our products.
And I'm Darron Antill, the CEO of Device Authority. We're a software-only solution focusing on device trust, data trust, and managing that at scale.
Fantastic. So I think it's, how many engineers do we have in the room here, design engineers in terms of hardware? Hands up, just get an idea of what we've got. It's got one, just the one? Or okay, what about firmware engineers, software? It's got quite a lot of software. Okay, interesting. So software security has been one of those things that's a sort of driven security for the past 20, 30 years, ever since computers were first around. But hardware security is one of those things that's sort of starting to get become more popular and used in devices. So I'd like to go through each of the members here and ask them why they think hardware security is becoming more important in their designs. So start with you, Lise.
Well, I mean, security starts from the hardware. I think that's the bit that people just about to realize. You can have the best cryptography design or I don't know, secure environment. On the software side, you still need a secure environment on the hardware side to run it in, and other challenges that it comes with it. So it's just impossible to ignore some criteria on the hardware side that protect the security of any software that you run. And then assume that you have security in your system. So that's just the basic fact. Cannot just ignore that.
Yeah, and I mean, expanding on that, it's important to realize that, I mean, this is IoT, right? You're putting hardware in the hands of a customer or in the hands of the end user. And as we've seen time and time again with solutions like DRM, that doesn't work unless it's actually supported by said hardware.
And I would just echo, I mean, at the end of the day, hardware is the foundation of everything. I think the challenge is ultimately who gets their hands on that hardware and how things are implemented. And it's a very fragmented approach to begin with. It isn't until you end up with a product or an end solution that then the real challenges, end to end become very apparent. But it's the first pillar, the hardware, where you need to get that right. It's foundational.
So basically, because as you were saying, essentially everything starts at the hardware. That's the first point of defense that we should be looking into, and as opposed to sort of looking at just the software trying to protect the hardware. Because I think what's interesting about software security is that the software security is designed to protect what runs on a system. But in terms of defending hardware, once an attacker actually, or a criminal has access to the hardware, generally speaking, they can do what they want with it. I think would be fair to say to some degree. Because once you've got, you look at these IoT devices, half of them have like JTAG ports still on them. So you can connect a programmer straight to it. You can get straight into the hardware. You can reprogram it. You can possibly look at keys that are stored in memory, unless it's got some sort of protected memory, which comes into the next point. So what I'd like to know is cryptographic hardware has been around for a little while now. We've got hardware random number generators on chips. But what would you say are examples of modern cryptographic hardware solutions that we're seeing coming to the market sort of now?
A lot of these things are driven by the applications that are happening in the world. For instance, right. IoT is a great example of that in different industries. There is a recent report by McKinsey that says there is this trillions of dollars of opportunity for the IoT market, which is kind of intact because of cybersecurity challenges that nobody really dare to really touch it. So those type of applications, or AI, for instance, makes us think about how can we use cryptography or any other sort of hardware security to enable those type of applications, enable those markets to actually expand. On cryptography side, a lot of things now moving towards how can you do fast but secure type of encryption or signatures to protect the integrity of the data, for instance, that is for an IoT application or AI applications, or protect the IP of the algorithm that runs on the hardware side. Also, another part of it is on how do we generate keys and protect the cryptographic keys. For instance, something that we do is this second generation of physical unclonable functions that help you to generate cryptographic keys without any parties involved, and without storing the keys inside the device. So even at a very, very powerful physical access to the device, you are still sort of protected.
But the problem is that at some point you have to have a key stored on a device. You can't get around that because it's the only way you can decrypt the information. So the challenge becomes how can you protect the key itself?
Yeah, so there are obviously challenges at the time of running an algorithm. There has to be some sort of key inside the memory on a register, of course. And there are other ways, I'm sure Steve could
bring in?
Yeah, I was going to say, at that point it just becomes about circles of trust. Like you have your inner circle, which you do want your hardware to support you for, where all of your root secrets rely. Sorry, and as a colleague said, physically unclonable functions are a big part of, enabling that, and then you just build layers on top of that, or circles around it, depending on if you're a line or a circle person. So that's what modern secure hardware should look like. It is supporting those circles. It's supporting that isolation between the different levels of your application.
So on the far end, we've got so your expertise is software, correct?
Yeah.
So how do you see hardware security? It's sort of interfacing with your software work.
Well, I think you're talking about establishing, your first root of trust, and there's many ways of effectively doing that. And I mean, you made a comment once a device effectively has been hacked and it's compromised, but there are ways of continually managing the credentials or the identities of those devices on an ongoing basis through its life cycle, and that's rotation of keys or other clever things that you can do. So, and I think that is the answer. It's not a one-time only thing, but you start from the beginning. So, secure by design is really what we're talking about. But then, how do you connect to those secure by design initiatives or the technology that's embedded in that, and then how do you manage it through the life cycle? And that's very important. And I think the biggest challenge, though, is then most of the people don't understand all of the requirements through the supply chain of what you need to do to address the life cycle that I just talked about. That's the biggest challenge, which moves on.
That's actually a good point, because I think one of my biggest concerns from an engineering point of view is that there are so many levels of security you have to consider. It's not just the hardware, it's also the software, and then it's things like the implementation of protocols, for example. So generally speaking, when you look at data moving around a device, there's sort of three main areas, I think, where it needs to be protected, in storage, in transit, and in processing. So, you take some data from a memory unit that's in transit on a bus. You need to protect that. Gets into your processor, it's being processed. You need to protect that while it's being processed, because there are, I think they're called sidechannel attacks, where you can get contents from registers in very unusual ways, and that's as that data is being processed, and you can infer what that is. And then once that data gets sent somewhere, then it's sort of like storage. Transit and then process. Yeah, so once it's being sent somewhere else around the internet, using IP protocols, that protocol itself needs to be secure. So my biggest concern with hardware security, in terms of sort of working with software, is trying to get the two to work together. So, any comments on that?
Well, yeah, that's a very good point. There is a gap between hardware security and software security, especially when it comes to applications like IoT. So it's important to have that bridge, and that's one of the things that we do, simplify secure by design for the OEMs or the end user who actually writes the software, to have the right libraries that runs on different MCUs that protect that and create that channel that you just mentioned, for instance, using TLS or MQTT for low-powered IoT. So it's important to provide the right tools for the end users, and I think from industry point of view, morally, we are responsible to build the right hardware security rather than just waiting for a customer to come to us saying, I need this type of cryptography. We already know what sort of cryptography needs to go there. But there is always this kind of marketing things that, customer first needs to ask for it. But I think when it comes to security, we need to take a different approach. We need to realize these can enable many opportunities for the end user and can save the end user without them knowing yet. And we should build that infrastructure as the leaders in the industry.
It's interesting you talk about tools, because things like, take like ARM microcontrollers, for example. If you buy an ARM product, they provide software tools, they've designed the hardware, they've designed the software, they've ensured it's trusted and all that kind of stuff. But you take something like RISC-V, it's open source, so everyone knows how it works. But the implementation's up to the person who decides to use it. And so the movement of things like open source hardware and software, could that be a source of security breaches, in the sense that there aren't the proper tools developed for those systems? Because if someone designs a RISC-V processor, you're relying on that implementation to be correct and to be secure. But you look at ARM, for example, which is proprietary, but they've got people ensuring that it's secure.
So I actually disagree. RISC-V can be more secure than an ARM processor because you know exactly what you're getting as a silicon vendor. And because it's open source, there's a lot of collaboration happening as well. And you've got actually bright minds in the industry coalescing onto RISC-V right now as the microcontroller alternative to ARM Cortex.
But the thing about hardware security is that RISC-V describes an architecture. It doesn't describe an actual physical construction of a processor.
Yeah,
so
right.
that's where you have. So I could design a RISC-V processor right now, and it would be it could have zero security, and it could be extremely easy to hack, but it would still run RISC-V code. But you take something like ARM, which is proprietary, they have designed it, and they've still got the financial backing to ensure that their devices are safe because they're used so often in the industry. So I wouldn't say that. Also, I wouldn't say that RISC-V is secure simply on the basis that lots of industrial partners are coming together to work on it.
It depends on which implementation of RISC-V. That's correct.
Yeah.
There are a couple of alliances around. I think there's two big ones who are kind of competing in a good way.
Sci-Fi is one, I think, isn't it? Is it called Sci-Fi?
Sci-Fi is a company. It's not an.
What one is do they not make the chip itself, or are they just building the computer? Because I know there's I think it's called Sci-Fi. They're doing RISC-V. Yeah, but are they implementing it themselves?
They are.
Yeah.
Yeah, they're like design companies that instead of you designing your things on RISC-V, they help you to do that. So you just tell them what you want, and they give you the RISC-V architecture for it.
Yeah. So then that comes to my next question, which is about sort of using like families of chips. So you take a company like Microchip, for example. They'll do they'll do the memory chip, they'll do the micro. So my question is it important for designers to try and keep all their parts in the same family or the same manufacturer under one roof, or is it okay to sort of mix and match in terms of security? Because you look at things like Intel processors, they have all kinds of Southbridge, Northbridges, all these kind of things, and they're all designed to work together and be secure. But I wonder, is there an aspect of hardware security that's improved by trying to keep everything under one roof?
You might get the benefits of staying with the same vendor because it is easier to work together, but I don't think there's inherent benefits of single sourcing your entire design from a single vendor, and that just might be talking against my own shop. But in the end, if you have multiple components in your system, there's a boundary, there's a clearly defined API to interact with that device, and there's always a way to design it to be as good as the single source solution. So
do you think that moving towards SOCs and stuff where everything's kept under one package might be safer than trying to use lots of random parts put together?
It is safer, and then you're talking about what is the effort required to attack the solution? Because if you're on a single SOC on a single die, suddenly the expense you need to take to sniff a bus becomes much higher, and that is the advantage. But if you're talking, if you're going to have a separate processor and a separate crypto engine, I would believe mix and match of vendors is fine. But if you can pull those into a single die solution, then that's obviously better.
So I want to move on to sources of driving progress. So why is it that we're seeing hardware security become more popular than it has ever been? So I'd like to bring it over to the software actually, because I think this is an interesting question, which is, do you feel like that consumers are becoming more concerned with privacy and security in general?
Oh, I think absolutely yes, they are. I mean, you've got compliance driving that awareness.
Yep.
Only yesterday the UK cyber security law, again, is further defined, making people more aware. You've also got best practices and standards. So people like the IoT Software Foundation, who's putting various guides or best practice templates together for people. So generally, there are bodies and compliance organisations creating the awareness. But I think as individuals, I mean, I'm a driver of a electric car, and I always notice the fancy things coming up on the dashboard about whether I'm in private or public mode, and I have to read the manual and investigate actually what all that means.
Yeah.
But these things are coming at us, and so I think there absolutely is more awareness. Now, we're typically a business to business as opposed to business consumer, but I think in the business space, people have to take responsibility for privacy and data. GDPR has been a significant thing just in the last few years.
Yeah.
So they have to demonstrate best practices or at least adherence to those type of things.
So, in terms of customer awareness, it's quite interesting how there are cases where customers can throw away a device. They've got personal information on it they don't realise, and then someone can recover that device and get the information. Now, one of the sort of ancient sort of ways that was done was computers being chucked at landfill. You might have bank statements, passwords stored in files. You don't wipe the hard drive, give it to them, and into the landfill, and someone picks it up, and that's why they don't let you pick up computers in landfills anymore. But in terms of awareness, how do you feel about customers in general not being fully aware of the security nature of the security of their devices? Like, for example, I think one of the new laws now says that manufacturers and manufacturers and distributors have to tell the customer how many years of support their device is going to have before it stops being supported. But do customers really appreciate what end of support means?
I don't think so. I mean, a great example of it right here, by show of hand, how many of you using the default password on your Wi-Fi hub still? Haven't changed it.
I didn't. I changed mine the moment it came.
Customer wants ease of use, and if security gets in the way, they don't feel comfortable with it unless there is a very a critical things that they really aware of it. I don't know, for instance, it's a medical device and they are really conscious about it and worried about it. But otherwise, kind of end consumer, I don't. People talk about it and people worried about it, but I don't see them proactively doing anything about it. I think it goes back again to the OEM responsibilities and semiconductor responsibilities to make things and build things in a way that is easy enough to use and is secure enough for people, or easy to manage during the device life cycle.
I can see you want to step in. I can see that. Yep.
Yeah, no, I was going to want to say that it entirely depends on who your customer is. This is true for consumer business, but business to business, I think they're way more aware of what security actually they want. Well,
you would say that, but which government agency had all their employees using personal devices and ended? Was it? I think it might have been the UK government. I think half the MPs or something were using personal devices, and it turned out half of them could be hacked or something. So I wouldn't say that business to business customers are entirely aware.
Government is a special case.
That's true. But sorry, Karen, what were we saying about the? Sorry, you're saying about the business-to-business customers being aware, but what about the customers themselves, like the end users?
Yeah, and the original question went on legislation, right?
Yes,
and that legislation is there now for a reason. It's a reactive thing, and it is because we have seen these large hacks in the past, and there is a tendency to not care as much. It's just another news item. Yeah. If the same day there happens to break out a war, then it just gets buried. And you don't really get that exposure. So it's a good thing that the legislation is there, and we'll see the industry converge on solutions.
I mean, you asked around the awareness. I think generally the awareness is up. If you just use the car, that came up earlier with the VCs talking about, the consumer is the person that buys the car. But from my experience, you're seeing, the life cycle of a car could be 10, 20 years.
Yeah.
But people are figuring out now, and they are concerned, and they're looking at solutions to how they manage privacy,
Yes.
so data security through the life cycle of the car with different owners and with different people interacting in that car. So they're looking to use, smart technologies that we referred to earlier.
Yeah.
So there is generally more absolute awareness with the business manufacturers putting things in place to address this, which I think is driving the ultimate consumer awareness.
But do you not feel like that the idea of bringing in regulation on and enforcing it onto engineers is somewhat of an invasion of your ability to actually design in the first place and innovate? Because obviously the idea of having security and ensuring that customers are protected, it sounds good in practice, but it might find that actually it makes things extremely difficult to design things, to get them out, and then the risk of being fined if you've made a mistake. So how do you not feel like that the regulation is just stifling your ability to design?
Honestly, this security awareness was already on the rise before the legislation came, so everybody was already kind of going in the same direction. I think the legislation just ensured that it actually happened.
Yeah.
And so in a way, because we were already going there, it doesn't impact as much because everything's already designed with those requirements in place.
And I wouldn't say it slowed it down. I mean, the regulation's been too slow, frankly. And if you're running a business in IoT and you're not concerned about critical safety or critical data security,
should be in the industry.
Exactly, or something severe will happen to your business if something goes wrong.
Because I think what I find quite shocking is how many IoT devices there are around the world. The last time I checked, I think there's an estimate of 21 billion. And those weren't designed today with all this in mind. This was designed back maybe 15 years ago. And this was at a time where an engineer would build maybe, I think I talked to you guys earlier about this, where they had a case in America where they had an engineer had designed, these engineers designed like a smart aquarium thermometer, and it's a great little device. We can connect it across servers and that kind of stuff. They stuck it in a casino's aquarium tank, and a bunch of hackers realized that gave them access to the wider network, which was very secure. But by jumping onto that thermometer, they got into the main network, then they got to the servers in the casino, then they got to the high roller information, and now they've got all the personal details of the people with lots and lots of money. And I bet it wouldn't be difficult to sell that list to some bad characters who might say, we can target these people for cash. So it's just stunning how it's stunning how it's taken 20, 30 years of, because we've known for years that the internet is extremely important. All this technology is extremely important. Bank details have been sent over the internet for the past 30 years easily. But when do you think it started? 1990s, 95? When did we start sending back information across the internet, do you think? Probably 95, 94? Quite
I think it was before my time.
Before mine as well, probably. So it's just shocking, I think, that it has taken this long. We've had this many devices, which all could potentially be insecure. But then my next question is, do you feel like that? Who's to blame? Do you think it's the industry, or do you think it's regulation? It's a trick question. It's a trick question. The answer is you, but carry on.
Regulation is important, and as my colleague said here, people were aware, and those awareness was going on in the market. Yeah. Regulations speeding it up and kind of forcing people or forcing those passive customers to actually do something about it. Who's to blame? I mean, when it comes to, different ecosystems have different kind of dynamics regarding IoT. There is a very, very complex ecosystem from the semiconductor to distributors to the manufacturers, OEMs, programming houses, that eventually ends up to either another business or a consumer.
That's interesting you mentioned about semiconductors, because on one hand, it's a bit like, when the new technology is introduced for the past thousands, since the dawn of the human era, every time we develop something, we see it for its good, and then it can be used for bad, right? So it's kind of like, the internet's great, we can send information. Suddenly you've got people, doing the most horrendous things you can imagine on there. And I kind of feel like it's a bit the same with silicon technology. So they sort of developed, I think it would be fair to say the reason why internet security wasn't such a big concern in the past, it wasn't just about the number of computers, but the fact that to develop that kind of hardware was very, very expensive. So computers were really the only devices that connected to the internet. Then suddenly they bring out SOCs, the ESP8266. Suddenly anyone can design an IoT device. So it wasn't just if you want to build an internet-enabled device, it didn't cost you $10,000 or $100. It was costing you $1. So then suddenly you can make 1,000 of them. And if you had untrained engineers who weren't aware of these sort of things, they could send out 1 million to the market, not realizing, and then suddenly, oh shit, we've got 1 million devices that are all insecure. So I think that's interesting you mentioned about that. What's your take on that?
In terms of the question, I just wanted to come back to a point you made about who's to blame. And I think we're in a world where we've been in the M2M market for a number of years, moving to IoT. You've talked about device security, hardware versus software, but it's not about blame, it's about what you're going to do. Yeah. There are many businesses out there who clearly have devices where the security posture wasn't thought of, wasn't conceivable of. And I think, no one's to blame for that. It's just the way it is. But I think with new digital devices or more transformations, people are now figuring out what they're going to do with the new devices. Yeah. And you made a very good point. There's a whole ecosystem now that needs to take this seriously. Yes. And from what I see, more and more people are, which is good. But there is another opportunity. Whilst they're looking to fix their future products, is what are they going to do about their old products already in the field? So, you talked about hardware. Hardware is really important for the new products, but it doesn't solve the problems.
The ones that are still out there.
So having a software retrofit solution, so that's something that we do and we look at. That is a way of being able to take care of some of the problems in the field. So you need to look at both.
Which is interesting you say that, because you've got life cycle stages of products. So when you create a device, it's on the market, it's in use, and then you've got to dispose of it. And so it becomes that problem, which is that if a device has keys or personal information on it when you dispose of it, the engineer now needs to think about what's going to happen when it sits in a landfill doing nothing. Is it still secure? And so I suppose this is where things like OTPs that can't be recovered come in. Because I think we were discussing, or was it somewhere? I was downstairs. Sorry, I was discussing earlier on with someone about how you wipe a key on a device once it's no longer used. So can you burn all ones so the key is destroyed? Yep.
Yeah, if you're designing a system now, I would say that you have a secure enclave, secure element in your system, which gives you the opportunity to store your keys and also gives you a verifiable token if you destroy whatever is on there, right?
Because I think the challenge is that if you've got a customer, you take an engineer and you say, right, here's a board, I don't want it anymore, I want it to be wiped. An engineer knows how to do that, stick a programmer in there, burn some ones, whatever. The problem with the customer is that they haven't got that kind of equipment, and I think it's fair to say that 5 to 6 billion people on this planet can't do that. And so if you've got devices out there, you need to make sure that they're secure when someone throws it across the room and then forgets about it, and then it can't be attacked.
Yeah, so if you have an internet-connected device, you should have a device management service that allows your user to interact with their device through the device management service, and that service will actually make sure that it tells the device not only to destroy itself, but also to confirm that it destroyed itself.
There's also innovation. For instance, you obviously could use cryptography with those tokens, what you enable, what you disable inside the device, so not everybody can have access to a device, but you also could use technologies like what we created as a physical unclonable function, which potentially means you don't need to store any keys inside your device, and because of the quantum tunneling processes, it's just secure against side-channel attacks or fault injections, etc., naturally. So innovation plays a big part into how we protect the future as well.
Now, moving the topic to hardware versus hackers, there's something I've always wondered a bit. So when it comes to software is actually an interesting one, because you can use it, you can have software security to protect systems that are running on a system, right? But generally speaking, software can't really protect hardware unless you've got things like tamper pins or some way for the software to interface with the hardware. And if you find that there's something wrong with the software, you can provide updates. Hardware is not exactly the same. If you design a hardware cryptography system that's got an inherent flaw, you can't change it. There's nothing you can do about it. My question, and I honestly wonder about this, is how much would you say that hardware security can introduce new flaws? And if so, is it possible for hardware security in the future to be built out of programmable hardware, things like small areas of FPGAs which could be altered to ensure that the hardware itself can be updated as it runs?
I think this is yours.
Yeah, this is yours. Definitely your area, not the.
Yeah, it's an interesting thought. I will say that much. I think the issue with programmable logic is.
10 minutes. Okay.
Oh,
sorry. We'll finish up this question. We'll move on to questions from the audience. Sorry. Last thing.
That's okay. The issue with programmable logic is that you have, the information about how the hardware works. Yeah. Then gets disclosed through whatever binary it is you're using to program that logic. And it will also be more easily glitchable. It's an interesting idea, but it needs some more maturing, I think.
Fair enough.
Software somehow protects it as well. I mean, we had in the case of Intel's and the kind of memory flows that they had, they basically updated some of the firmware to protect to some extent and solve the issues, for instance, in Intel CPU. So sometimes you can still play with the software to protect and address some of the flaws. But generally, if you messed up,
I think it's, the designs these days are a bunch of hardware primitives that, there's software around it that honestly I build, which is encrypted and signed, that uses those blocks. So as long as the flaw can be worked around by the software that sits on top of it, you're still fine.
Right, I'm going to have to wrap it up there. And we're going to now move to questions from the audience. Any questions for the panel members? None at all? What's up? Yeah, sure. Oh, I didn't see it. Sorry about that, yeah.
So just going back to the destruction of devices, a landfill, one of the reasons why people throw them away is because they've stopped working, as in the power supply has gone. So I'm thinking, how do we actually wipe the keys, or how would a user wipe the keys or wipe the device if the power's gone?
I tell you what, that's a really good point, because I myself am extremely lazy. So you talked about like having, like in that case, you talk about having like management systems and software interfaces to allow customers to destroy the devices. I know my mum and dad wouldn't do that, just chuck it in the bin.
Depending on the end user. So if we're talking about on a business side of things, for instance, through our platform, ClarkLink, which I'm sure you guys also doing the same thing, you have management over all the credentials or certificates of those devices, and with a click of button on that platform, you can wipe out millions of devices and they just get disconnected.
Can I just admit on camera, I accidentally nearly did that. I worked for a company, I'm not joking, I worked for a company and they designed these IoT devices, right? And my manager said, right, program a thing that allows me to change the details on it. And I started doing that, and I was randomly going through MAC addresses, and I didn't realize they were using MAC address as a way to register a device onto their system, and I must have wiped about maybe 1,000.
Well done.
He didn't tell me it was MAC addresses. So that was an interesting experience. Sorry, Karen.
That's one way of it. The other way is if you have a more sophisticated hardware, using, for instance, physical unclonable functions like Qt that we have, then you potentially don't have any secret keys stored inside your device. So on the hardware side, if the device is off and not being used, inactive, there's not really anything to get at. So you're not losing anything. I don't know if you, Darren.
No, I would just add, you said the same thing, a software system to connect to make sure they manage the keys. And if that device can't be identified or authenticated, it can't do anything. And I just hope, I guess, as a human being, we have a better sustainability agenda, that we don't keep throwing things in landfills, so remove some of the problem.
I mean, going back to the original problem statement, I think this was, a device that still has credentials and then lost its power supply, so it ended up in the landfill. But if you were to acquire a new power supply, it would still work, or theoretically still work.
Unless something on the PCB itself is damaged, which a customer can't do. Exactly. Yeah.
Yeah, and then if hacker or adversary gets their hand on the device, if they power it up, it should still connect, right? So what do you do about that? Honestly, there's nothing much you can do about it. keep track of your devices. Take a big hammer.
But you see, that's where I then think you have the idea where you should be able to send the device back to the manufacturer for disposal. Isn't that the WEE rules already or something? I think you have the right to send it back to the manufacturer, who then has to dispose of it correctly and carefully. Anyone familiar with the WEE regulations? It's a little bin icon they always put with a cross through it. Yeah, I think there's something about that where you can send it back. I'm not quite sure though, I'll be honest. I think you can, but...
the hammer still works.
But in that case, you would have to send it back, I would say, so that the manufacturer themselves could then dispose of it correctly and ensure the data was wiped. Any other questions? Got one over there.
Hi there, thanks for an interesting panel. I'm just wondering if you're seeing anything in the market pull towards people wanting to use crypto to own their own data. I'm just thinking, in terms of your car, for example, is connected to the manufacturer. They know where you drive, how often you drive, all of that data is yours. And you potentially might want them to pay you for it, like a car wallet.
Well, I think in answer to your question, is crypto, I mean, I think there was a report out this last week, the Ponemon report, an industry standard report, where now IoT is the primary driver for PKI as opposed to enterprise. You know, so to your point, people are seriously thinking about it, and the end customers or the business models addressing the end customers are all looking to use PKI, so key management, exactly for that point. So it's now the number one area of focus.
Any other?
So we haven't seen anything that people want money for their own data, but we've seen cases that people would like to protect, especially on the AI side, the algorithms and the parameters that they use for the AI on each device separately to keep it encrypted all the time, or for GDPR reasons, make sure the data is always encrypted on transit or storage at a kind of a back office or a cloud service. So we've seen these things that they want full control over the cryptographic systems or PKI systems. They don't want to share it with the OEM or any other party, including the cloud sites. But we haven't seen anybody wanting to monetize the data back to the OEMs, etc.
But monetization could seriously drive the idea of protecting data in the first place, and it could give companies incentive, because if they then start paying for the data, they could get high quality data anyway. Sorry, Karen.
Yeah, and I mean, in the case of the car data, I think GDPR was a very, very big step in that specific use case as well, because as long as the car manufacturer doesn't have a genuine interest in that data, they're not even allowed to do anything with it.
Yeah, but I think one of the concerns, though, I can tell you right now, everyone in this room has done this, which is that you've got terms and conditions. Scroll, click, next. Nobody here has ever read that. Anyone who's actually read a full terms and conditions. Ignoring him. Anyone who's actually read ignoring him because he's not got a life. Because those things are too long. And I think what you find is that when you buy, it's amazing that you can purchase a vehicle and you go, you have terms and conditions to tell the person you bought the car from that they're going to be seeing where you're driving. Now, I appreciate it might be good things for like AI and big data and stuff, but I still think things like GDPR can be worked around by including terms and conditions, like cookies. Everyone clicks accept all, but they don't really know what they're accepting. So I think, I would say that the regulation in that area still is weak, but that's just my personal opinion, I think. So I think we have to wrap it up now, do we? Yeah. Anyway, thank you ever so much for taking the time to be here, and please give my panel members a round of applause. Thank you very much.